Hi, Mark. Mark?
Hit it.
Yeah, there you are. I was just about to tell you might need to unmute your mic. Okay. So we're back to regular polygons.
Yeah.
Okay.
Well, it's just review for a test we have.
Okay. No, that's fine. I mean, I don't really care. But I thought you were on to circles, but maybe there's a test that covers both. I don't know. So number one, what's the very first thing we need to write or think?
Is with the apothem.
Not quite. I would like you to treat all geometry problems in this way. Write the general formula for area. Always start out your problems that way.
Okay.
So what's the area equal to?
Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9.
What's the general formula for the area? That's what I want to see right on every single problem, is the general formula.
A equals BH.
That's for a rectangle.
Oh, okay. So 1/2. Shoot, what is it?
Bottom times the number of sides times the side length.
Okay.
Which also is 1/2 the apothem times the perimeter. Because notice that the number of sides times the side length is equal to the perimeter. So either of these formulas works.
Okay.
In general, I like the one on the left. Even though it's longer, the fact is that we don't often get the perimeter, but we do get numbers like the apothem. We can count up the number of sides, and we have side length. So for this particular polygon, fill in all the unknowns here.
Okay. Well, the apothem is 57.7.
Number of sides?
9.
And the side length.
And then the side length, is that 61.4?
No?
Oh, 42. Okay.
Yeah, it's the outside measurement. In other words, they threw this in there just to kind of confuse you. That's the distance from the middle to the vertex. And that sometimes is called the radius also. Even though it's not a circle, if you were to inscribe a circle about that nonagon, that would be the radius length, because the outside of the circle would go through that point. Okay?
Mm-hmm.
All right, let's look at number 2.
We're using the same equation for number 2, correct?
Yeah, and I mean, I just cannot overemphasize it too much, how important it is to start off every geometry problem with the general equation. In other words, if I tell you what's the area of the rectangle, you should start out with area equals base times height, and then fill in what you know. Okay? Now, sometimes you can skip that step and get away with it, but on these regular polygons, this equation is not that well known. You could ask an awful lot of math experts, and they would not be able to tell you what the equation for the regular polygon is. This is kind of specific to geometry class. You're not going to need to know this for your ACT test.
Okay.
Okay? But you do need to know it for geometry class. So, okay. So in number 2, what can we fill in?
The apothem is 26. the number of sides is 6, and then the side length is 30.
All right. Now, I'm not going to go through these to come up with an answer. I assume that that's no problem, especially if you have a calculator.
Yeah.
The whole key here is figuring out that the apothem is the thing that makes a right angle with one of the sides. That's what the apothem always does. It never connects to the vertex. In other words, I could draw the apothem from there to there, or I could draw the apothem from there to there. It's going to be the same thing, but the key is that right angle. Oops, hold on. All right. Now they get a little tougher. Hold it. I'm going to leave that equation up because you still want to always start out with the general equation.
Okay. So what we have is the number of sides, the side length. We don't really have the apothem.
Tell you what, tell me everything you know.
Well, the side length is 60. The number of sides is 5. And I don't think we have the apothem.
Okay, so the apothem we have to figure out. Okay? So let's draw the pentagon. Now, typically the way you analyze regular polygons is you connect the center to each vertex, and you break up this 5-sided figure into 5 regular triangles. All these triangles are congruent.
Okay.
Okay? Now, the measurement that we know is 50, right?
Mm-hmm.
But that doesn't help us with this formula because the radius is not one of these A, N, or S. So let's draw an apothem. This is my right angle. And now let's analyze that little triangle. I'm going to draw it separately out here. That's 50. Do we know this side right there?
Yeah.
What is it?
30.
Okay. Now we have a right triangle that's a 30, what? 50.
You could use the
Pythagorean Theorem. You could. Let's go ahead and use the Pythagorean Theorem. Tell me how to get H. Well, let's call it A. That's the apothem, actually. So what is A equal to? Using the Pythagorean Theorem. This is an important one. You should always, and I mean from now until you get through your first year of college, you should instantly know how to solve a right triangle using the Pythagorean Theorem.
The side is 40.
What's the other side?
The apothem is 40.
Okay. Tell me how you did it, though. I want to make sure you know how to solve a right triangle. In other words, there's 2 ways to do this problem. One is to recognize that you're looking at a 3, 4, 5 triangle. Okay, that's the easy way. And that's how you came up with 40. But let's make sure you can solve it using the Pythagorean Theorem. What is A equal to?
A equals 50 squared. No, just kidding.
Answer, when you're solving right triangles and they give you 2 of the sides, the third side is always square root of something. That's the way your words should always start. It doesn't matter whether I'm solving for one of the short sides of this triangle or whether I'm solving for the hypotenuse. my answer always begins square root of. And if you can remember that, you won't make any mistakes. What goes inside the radical?
The square root of 30 and
It's very specifically
square root of 50 minus
hypotenuse
30
squared minus the other side squared.
Yeah.
Okay, do the math on that, and you get A equals 40.
Yeah.
But
Yeah.
this is very important that you can do that quickly. Notice that I did not go all the way back to c squared equals a squared plus b squared, which is the Pythagorean theorem. And I don't want to go all the way back to that because, first of all, there's only two questions when solving right triangles if they give you two of the sides. And that's either you're solving for the hypotenuse or you're solving for one of the short sides. If you're solving for one of the short sides, it's always the square root of the hypotenuse squared minus the other short side squared. If you're solving for the hypotenuse, it's always square root of one short side squared plus the other short side squared. Notice the difference.
Okay.
When I'm solving for the hypotenuse, what goes inside the radical is a plus sign. When I'm solving for one of the short sides, what goes inside the radical is a minus sign. And you always have to put the hypotenuse squared first. So it would be very useful for your geometry education for you to remember those two formulas right there, directly.
Okay.
In other words, you can derive both of these from the Pythagorean theorem. But the thing is that this is probably the most common task you're going to be asked to perform in geometry. And I don't just mean this year, I mean next year and the year after and the year after. And that is to solve right triangles. So being able to do it directly saves you a lot of time and mistakes by being able to memorize both of those. And part of it is just always remember that it starts square root of. Now this answer ends up being A equals the square root of 1600, which equals 40. But it still started out square root of. It just happens to be a number, a whole number. Okay?
Yeah.
All right. So, if we know the apothem is 40, now, obviously, the easier way to do this problem was to recognize that we're looking at a 3, 4, 5 right triangle. So we don't really need to go through the Pythagorean theorem to solve this. You want to recognize 3, 4, 5 triangles. That's the other thing. All the tests you take on the ACT, the SAT, you're going to run into a ton of 3, 4, 5 triangles. Now, I call this a 3, 4, 5 triangle even though it's 30, 40, 50. It's, when I say a 3, 4, 5 triangle, I mean or multiple of such. Well, this is a multiple of 10 of a 3, 4, 5 triangle, but that doesn't change anything. In other words, as long as you're given the 30 and the 50, it's pretty easy to figure out the 40. As long as you recognize that you're looking at a 3, 4, 5 triangle. Okay, so now we know the apothem. We can write that in there. Now it's just filling in for each of those three numbers. Okay?
Yeah.
Solve this right triangle for me. What's x? Don't give me a number, give me the setup. You know?
Okay.
In other words, x is the square root of what?
The square root of 7 squared minus 2.
Minus 2.
Or 7 minus 2, I guess.
Remember that everything inside the radical sign gets squared. Everything. Whether you're solving for the hypotenuse or a short side. Let me give you this side. Solve that. What is x now?
For x is 6.
No, give me the setup. I don't want the answer. I want the setup.
4 squared plus 2 squared.
Okay, how does it start out? X is what?
X is the hypotenuse.
But in the formula, when I write x equals, what's the first thing I have to write on the other side of the equal sign?
X is the square root of 4 squared plus 2 squared.
That's what I didn't hear the first time. It was the square root of. So that's the answer. Okay. All right. Remember, and those are the only two things you have to know. It's how to solve for the hypotenuse or one of the short sides. So there's really only two equations you have to memorize. All right. Let's go to number 4. Again, we're on regular. Oh, goodness. What is a undecagon? That must be 13 sides. No, what is that?
I thought it was 11.
I think you're right. A unidecagon. What is a unidecagon? Wow. Huh. Let me take that space out. 11 sides. I didn't know. That's the last thing in the world they should be asking you to do in geometry. I'm sorry, it's just that's my belief. That you should not be forced to learn what these words mean, especially the ones that you never see. All right, so what's the general formula for the area?
A equals 1/2 ASN.
Okay, and what do we have here? So tell me what to write next.
A equals 1/2.
Hold on. Notice one of the pieces of information they give you is A. In fact, what are we supposed to solve for here? We're supposed to solve for
the perimeter.
Really?
Mm-hmm.
On number 4?
Yeah.
Where does it say that?
Down a little bit.
Oh, okay. So I see. I got it. Okay, so we're solving for the perimeter. Okay, so what should I fill in for A?
1680.36
equals
1/2 22.8 times 11. No, times S times 11.
What is S times N equal to? Another name for that. Number of sides times each side length. That's perimeter.
Yeah.
That's perimeter. In other words, I can cross that out and write perimeter. So now, solving for the perimeter is easy. There's only one variable in that equation. It's P. So it is helpful to know that this is also equal to 1/2 the apothem times the perimeter. In other words, it's helpful to know that S times N is the perimeter for problems like this. If you didn't know that, in other words, if you knew this one, you'd be all right. But if you only knew that and you didn't know that the perimeter was S times N, you wouldn't be able to solve that problem. Okay. I'm going to leave both general formulas up there because I noticed that one of the pieces of information they give us is the perimeter. They don't give us an S or an N.
Yeah, they do. Oh, no, for
No, they
number
don't.
5.
Yeah, they want us to solve for the apothem. So what should I write next?
You could do...
In other words, we're going to use this formula right there.
Okay.
Now just substitute in everything they give you and see if you can solve for the unknown variable. What two things do they give you?
Perimeter and area. And number of sides, I
They give you
guess.
area, they give you perimeter. That's only going to leave the apothem as an unknown. And as long as you have one equation and only one unknown, you're always going to be able to solve for it. So what's the next thing I should write?
Try and find the apothem.
Let's just follow the formula. I'd kind of like to see you get into a habit of just following the formula. Yeah, you're right. We're trying to solve the apothem, but we're going to do it by following this formula. In other words, you need to come up with an equation that you can solve. That is the secret to geometry. It's not to try to solve it without an equation. We have an equation right there. There's 3 variables. They're giving us 2 of them. So if we fill in these 2 variables where they're called for, we'll only have one unknown, and that'll be little a, the apothem, and that's what they want.
Okay.
So what's the next line?
Okay, so it's 10393.6 equals 1/2 a times 371.2.
Okay, now let's make sure that you know how to solve that.
Okay.
Okay, since that's so critical in all of these problems, so far we haven't solved any of them. We've just set them up. I've assumed that you could do the algebra. Let's just guarantee that you can. What's the next step here?
You can divide 10393.6 by 371.2.
Okay, so let's do that. Takes that out from there. What's the next step?
Whatever that equals, if you multiply it by 2, you get a.
Okay, so we're going to multiply by 2. It gets rid of that, and that's what the apothem is. I don't have any concern that you don't know how to get that. I'm certain you know how to get that. So, okay. Let's see. That was number 5. Let's try to finish number 6. Ooh. Might have time. Always start. What's the general formula when you're talking about regular polygon?
A equals 1/2 ASM.
Okay. They want the perimeter of the shaded region. Well, they give us an area. They give us A. So I could figure out the perimeter of the entire region. But to get the perimeter of the shaded area, I basically need 1 side, 2 sides, 3 sides, 4 sides, plus 2 radial lines. Okay, so I'm going to need to figure out an S. In other words, just knowing S times N isn't going to do any good, and we don't have it anyway. They did not give us the perimeter of the figure. We can count the number of sides. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So we can substitute 10 for N. Now, the only unknown, we can substitute the apothem, 27.7. So we need a side length. We need to figure out what one of these side lengths is. Well, the way to do that is to make one of these triangles. Okay. In other words, the triangle is going to look like that. This is the apothem, 27.7. The thing we don't know that we need to know is this angle. Angle number A, or alpha.
Okay.
If we knew that angle, then we could use trig to figure out x, which is half the side length. You see why it's half? When I draw these triangles, if I take this decagon and draw it up into 10 triangles, each triangle looks like that.
Yeah.
Okay. What's this angle right there, total?
45.
Got 10 sides. There's 10 triangles. What's the sum around the point? How many degrees?
360 degrees.
Okay, so if there's 10 of those.
So each one of those is, well, both of those together is 36.
Okay, which makes each one
18.
That's 18 degrees right there. Now, give me a trig function that lets me solve for x. What trig function relates x to 27.7? The only two values we have. Tangent.
Tangent, yeah.
Tangent of 18 degrees equals what?
27.7 over x.
Other way around. Opposite over adjacent.
Okay.
Notice that the opposite to 18 degrees is x. It's SOHCAHTOA. TOA is T-O-A, meaning opposite over adjacent. So I'll shorten it up here. That's going to let us solve for x because that's just a number. We can multiply both sides by 27.7. We can come up with a value for x. What is s, which is what we need, relative to x?
What do you mean?
It's twice whatever x is. In other words, when I pulled that triangle out, I'm only looking at that little tiny triangle right there. That doesn't give me the side length. X is not the side length. X is half of the side length.
Okay.
So I have to double my answer in order to get the side length. Once I have the side length, now I can come up with the perimeter. And just before I let you go, I know I'm a little bit over here. The perimeter of the shaded region is 4 side lengths plus 2 radiuses. Well, I can get the radius from that same triangle. The radius is y. And I can use a trig function to come up with it. Okay?
Okay.
So once you come up with y, in other words, the distance from there to there, now you can figure out the perimeter of that shaded area. So this is not an area question. It is figuring out the side lengths and the radial length. And then you can figure out the perimeter. All right. Apologize for keeping you over a few minutes. Mark, I will talk to you next Tuesday.
All right. Thank you, David.